Hello everyone, I am Saiyam Shah. I am pursuing my Masters in Construction Engineering Management from the SEPT University. In the first semester of program as a studio project, construction project formulation and appraisal, I have undertaken the feasibility study of sewage treatment plant. The feasibility study of project focusing on the inception and development stage of project life cycle. This portfolio briefly demonstrates few processes undertaken as a part of this study, such as location analysis, demand analysis, stakeholder management, design brief, and conclusion. Project brief for sewage treatment plant. The graph shows city's growth over the year of 1850 to 2006 in terms of population and area. Type of project is greenfield project with area of 30,000 square meter. Technology used for the biological nutrient removal is sequencing batch reactor. Client is municipal corporation and it will treat the wastewater up to secondary treatment. Most of the sewage flow from the entire city passing through the long length of sewage system before reaching to their main sewage treatment plant. For that decentralization purpose, a 60 mld of sewage treatment plant is being constructed to treat the raw sewage by providing appropriate treatment. Location analysis. Location analysis is an important tool which indicates the feasibility of the project based on location on macro and micro level. This tool helps for choosing the best site location for the proposed sewage treatment plant. The entire city of Ahmedabad is taken into consideration for the macro analysis as a location with significant need for the sewage treatment facility. Two rivers Narmada and Khari are taken into consideration for the macro analysis. The graph shows sewage treatment requirement in 7 different zones in the Ahmedabad city. North zone has 140 mld of sewage generation with 0 mld of sewage treatment capacity in that particular region. Parameters considered for the macro analysis are land type, slope of land, self-cleansing capacity, distance between plant and river, distance from any wetland, and distance from any industrial estate from that particular plant. After giving weightage through analytical hierarchy process, Sabarmati River will be the better alternative for the disposal of treated wastewater. Although North Zone is an upstream side of the river, it is much preferable for the disposal of treated wastewater because construction cost of sewage network will be very high for the Khari River. For the micro analysis, two site location is taken into consideration from North Zone. The first one is near to the Koteshwar temple and the second one is near to the Kutarpur water treatment plant. Parameters considered for the microanalysis are area which is served by proposed sewage treatment plant, land availability, topography, location of dispose, current situation and future expansion. The highest weightage is given to factors like area served and land availability since the project would not be feasible in that area without these factors. Kodarpur will be the preferred location for the proposed sewage treatment plant after considering all the factors such as including topography, disposal location and the current state of sewage in that particular region. Demand analysis. After finalizing location, demand analysis for that region is carried out for forecasting design capacity of sewage treatment plant. Economic growth, pollution, centralized network, population growth, public health, and land use change are some different demand drivers for the proposed sewage treatment plant. The graph shows the population growth in the city from 2001 to 2051. The 2021 data will be taken from census department and the 2031 to 51 data will be forecasted using different three methods such as arithmetic increase method, geometric increase method and incremental increase method. The image shows that the sewage has to travel from north zone to south zone which is approximately 22 kilometers away for the treatment of sewage water which will lead to increase in maintenance issue in the whole city. The charts shows different survey conducted in North Zone for understanding current condition in that region. Three areas are taken into consideration such as Sardar Nagar, Kuber Nagar and Nana Chiloda. Figure shows that increase in land use from 2001 to 2021 in Nana Chiloda area. Table indicates the cases of malaria from decade to decade with STP numbers. Hence, increase in STP will lead to reduced health issue in particular Ahmedabad city. Sewage generated is directly proportional to the population of uh, hence currently in 2021 three areas generated 42.7 mld of wastewater. So any STP will be designed for the period of next 30 years. Considering these three major locations in North Zone, 60.8 mld of sewage treatment plant capacity is required. Hence, the 60 mld of sewage treatment capacity will be required for particular North region. Stakeholder management. Methodology adopted for the stakeholder management exercises identification of stakeholder, differentiation of stakeholder based on their involvement for the particular project, analyzing stakeholders' power, interest, influence and impact, and then prepare power, interest and influence impact matrix which will indicate the involvement of stakeholders for proposed project. A stakeholder is an individual, team, or organization that could directly or indirectly impacted by or have an interest in the project or its outcomes. Uh, there are total 37 different stakeholders identified for the sewage treatment plant, which are grouped into seven main categories such as client, central level authorities, state level authorities, local level authority, consultants, contractors, and end users. The first metric shows relationship between power versus interest for each and every stakeholder. The stakeholder who have highest power but least interest will be categorized under keep satisfied section. The stakeholder who have highest power with high interest will be under manage closely section. The stakeholder who have low interest and low power will be categorized under monitor section, and the stakeholder who have highest interest but have some low power will be categorized under keep informed section. Standing committee, although they have some important decision making committee in Ahmedabad Municipal Corporation, but they have low interest for the particular project. Assistant engineer have some responsibility for towards the project, so he have higher power with higher interest. Equipment supplier have low power with low interest, and EPC contractor have highest interest with low power. Same as second metric shows the relationship between power versus influence matrix. In that Central Pollution Control Board, which is nationalized as agency, will be under keep satisfied section. Ahmedabad Municipal Corporation under manage closely section because they have high power and high influence on the project. Surveying agency have low power with low influence, so they are under monitor section. And feasibility consultant who have highest influence on the project with some low power will be under keep informed section. Same, the third matrix is influence versus impact matrix, in which beam consultant is under keep satisfied section, local resident which have high impact and high influence on the particular project. Uh, then labor contractor will be under monitor section, and deputy commissioner will be under keep informed section. The below graph shows the relationship between impact, influence, interest and power for each group of stakeholder, which is client, central authority, state authority, consultant, contractor and end users. Municipal commissioner has and standing committee has the highest power and impact on the project, but the feasibility consultant and EPC contractor have very high interest but with some low power. They are working for that project. Design brief. Design brief is a document provided by client to designer which include minimum requirement for the particular project. The minimum requirement for the sewage treatment plant which is given by client is minimum 60 mld of capacity should be required. Selected technology consume less power for the treatment. Treatment should be as under prescribed limit as per CPHO manual, and the conveyance network from pumping station to plant should be provided by the contractor. The different sewage treatment plant components are receiving chamber, coarse screen channel, inlet chamber, fine screen chamber, grid chamber, biological lateral removal tank, chlorine tank, sludge house, admin building, and which is all included by SCADA system. The client provided a design brief report that aids in understanding the plant's capacity, the conveyor network, and the minimum requirements for the operation and maintenance of the sewage treatment plant. The first component is receiving chamber, which include minimum design flow is 60 mld with peak factor of 2. So the peak sewage flow will be 120 mld and the hydraulic retention time will be 60 seconds at its peak. The another component is biological literal removal tank, which is design flow in that is 60 mld, number of basin not more than 4 numbers, and the type of technology used will be SBR, MBR or MBBR. So EPC contractor can choose any technology from SBR, which is sequencing batch reactor, MBR, which is membrane bioreactor, and the MBBR, which is moving bed bioreactor, because it required operation and maintenance for 10 years by itself to the EPC contractor. The third is the chlorine contact tank, in which number of toners will be 5 number, which is minimum requirement, and capacity of each toner should be approximately 900 kg. These different four activities helps to understand the feasibility and pre-feasibility stage of project life cycle. In the location analysis, two discharge point for this plant are taken into consideration for the macro study, with Sabarmati being the best choice. In micro analysis, Kotarpur is the best position considering all the parameters. In demand analysis, different parameters such as population growth, waterborne disease, and centralized network is taken into consideration. And after doing the gap analysis, 60.8 mld of sewage treatment capacity is required from 2021 to 2041, because any sewage treatment plant will be designed for 30 years of its lifespan period. In the stakeholder management, there are total 37 different stakeholders identified, which are grouped into 7 main categories, and each stakeholder is given importance based on their power, interest, influence, and impact metrics. In the design brief is a document which is generated by the client and that outline the project's essential requirement and specification. Any technology from sequencing batch reactor, moving bed biofilm reactor, and membrane bioreactor can be chosen by contractor, because he has to operate and maintain the same technology for the next 10 years. Thank you.